Hello, welcome back to my bench. If this is your first time here, welcome, glad to see you. My name's Dave, and I fix electronic stuff, mostly for radio stations and the like, but I delve into other things too, and sometimes ham radios, sometimes I even did one on my car, my motorhome, which I no longer have. But thanks for showing up, and don't forget to hit that like button and subscribe. It really helps, guys. It really does. If you like it. Today, we have an antique. It's a plain metal box with a warning sign on top. No. This is a Harris AM limiter. I'm not even sure how old this thing is. But I can guarantee you it is not new. I don't know, wait a minute. If I look on here, I wonder. I've got the manual, well, some of the manual. And we'll see if it's got a date on it anywhere. No. It does not appear to. Thank you, Steam Power Radio, for the manual. I really appreciate it. Anyway, I believe this thing was back in the 70s. It was pretty high-tech for its day, and it did a pretty good job. And this one don't work. So, I have a new client that has given me a whole bunch of stuff that doesn't work. I think he's been collecting it for years. But that's okay. I have a lot of fun doing this stuff. Some of it's just routine stuff, and some of it's not. But this one, I think, is going to be fun. So let's take a look at it and see what we got. On the front of it, we've got an input pot. Well, we got this meter over here, which is limiting, so it goes from 20 to 0. We got an input meter, an attack set, how fast it goes into its limiting. ASIM set, which is used, I believe, for AM. This is an AM limiter, but I don't know. If people wanted to use it for FM, I think they could too. This is your output level. This is for disabling, not enabling, disabling the limiter and the phase of the output. And this is your recovery. This one, attack, is how fast it goes into it. The recovery is how fast it comes back out of it. I'm going to have to put a little goo in there. Something in there to get those to work a little better. On the back, there ain't much. On the back, we have AC line cord, fuse, and ins. Isn't that funny? Ins and outs. That's it. You got goes in, goes out. That's all there is to it. And the insides are, well, old. Ta-da. These things, this era, can be surprisingly difficult to work on. For one thing, it's all through-hole stuff. It's all point-to-point wiring. And as a result, if you want to get anything, if you want to do anything on the bottom of this board right here, you got to take off all, or at least one whole side, two whole sides of all of these wires that connect it. Because you can't, you can't just pull the board out. And, of course, if you look at the bottom, there's no opening down here to play with, to open up so you can get to the bottom of it. This stuff was not designed to be, worked on. Anyhow, but we're going to try. So I guess it shows signs of having been in it before. There's a couple of places where the solder's taken place. and a couple of things on the board here where I can see somebody has done something to it. But I don't know. I don't know what its background was. It just showed up for me to fix it. So, we're going to take a look at it. I've got it sitting on the. Oh, I got a new toy. Show you guys. Where is it? Ah, yeah, there you are. Wrong way. I had a guy send in a thing for me to fix that required 240 volts, so I had to go out and buy that. It was only $38, but hey, it works. And I got it hooked up, going through my little thing you guys have seen before, my little light bulb limiter with the kilowatt meter on it. That's how I do it. It's got an on-off switch and a bypass switch. And I also picked up another toy. I picked up that. That's cool. That is made as a CDM for doing phones, but it will do any frequencies between 100K and 3 gigs, 3.3 gigs. And this one has the Spectrum Analyzer mod in it, built into it. It's an Anritsu MT8802A. I am so happy, and I now have a 3 gig frequency generator and a 3 gig Spectrum Analyzer. Cool. That's neat, and it was not expensive. All I had to do was change out the battery on it. The internal battery was dead. So anyhow, let's back on this thing here. I guess like all things, I guess the best thing to do is to check voltages before we do anything else. So let's get the schematic up here. Oh, that's a mite large. Let's shrink it down, put it over here, and just bring up the part that we need for the power supply, which is right down here. Okay, I hope you guys can all see that, because you'll be able to see when I get into here too. All right, so it looks like I've not worked on these. Matter of fact, I've never even seen one of these. So we're going to be going into this together. It looks like this power supply is all back here, and there's not much back here. There's some caps and some transistors and some coils. A coil. These little buggers are expensive these days. Let me tell you. Wow, they're like. Big money. And I remember those things. We had a bucket of them at the radio stations. I wonder how much I could. No, never mind. Anyhow, so we're going to check the voltages on this. It's on light bulb. There's no on-off switch on this. It's on or, well, why would you turn it off? I mean, it's in service all the time. And we're going to check and see what we got for voltages. So according to the schematic, we've got 56 volts right here. And minus 56 here. What else? 39 volts and minus 30 volts. That looks like about it. So, where can I find a ground? Ground. Well, let's see, look around. Well, wait a minute. Is ground? Yeah, okay. See, off the center tap of the transformer right here goes over ground. So, yeah, cool. That makes life easier. Ground. Okay. So, first thing we're going to do is we're going to check the 56 volts. Let's turn it on and see what happens. Well, got to turn on the AC first. Okay, no light bulb. No lights. Well, lights. That's about it. Okay. Not drawing any current. Let's see, what's it got? Wattage. 12 watts. 0.12 amps AC. So it's good. And I'm putting about 119 volts into it right now. So we get the Vici meter up here. We're on DC volts. And we want to look at the where is it? R71. Where's the, okay. 10 ohms, 2 watts, R71. I believe this side is all power over here. At least it looks like it. So, where's R71? 76, 25, 55, 32. Hike. 74. Well, where's the diodes? I got CR17, and where CR17 and CR18 come together. So what I'm looking at here, I'm going to take right here and see what that voltage is. And that is what CR17 and CR18 come together, which is right there. So we got 56.3. Oh, that's good. All right. So if we go back 39 volts at, where could I get this? C26 is a 500 at 50. 23, 24, C26. Okay, I found C26. C26 is over here. So if I go here, 39.3. Perfect. Okay. Well, that's working, and including that the regulator. We look at the regulator. There's a regulator right here. So that's all working, evidently, and there's adjustments for it. They're all on here. R77's up here. All right, so now let's go to the other side of it, which is CR16. And CR16 is over here in this pile. 18, 17, CR16. This is going to be a negative voltage. We got negative 22. We're supposed to have negative 56 volts. We got something bad going on with the transformer, like a bad winding or something. I don't think so. I don't know. Let's put it on AC, and the transformer windings are right here. I can see them coming out. There's two yellow ones, and the other one goes to ground. So I'm on ground on that side. We got 46 volts on one side of it. We got 46 volts on the other side of it. So that should be about 90 volts across it. 99 volts across it. Okay, well, the transformer's fine. Okay, let's go to diode test and see if we got a bad diode. I don't know if this thing shorts out good or not. Yeah, it does. Okay, cool. That's good enough. Alright. Get off of there. So we're on diode test. CR16 is 0.51. That's good. The other direction, 2.8. Okay. Let's compare that to CR17 and 18, which are coming off of the plus voltage. 0.48 backwards. Yeah, it's climbing. And 18, 0.48. And reverse, it's climbing. Okay, well, so what do we got here? We got this diode right there, and a 100 ohm resistor drops it down, so it's current limiting resistor. We've got this capacitor, 100 ohm resistor, dropping it down to 55. We've only got 22 or 23 at this point. And a 3.9K with a Zener 4751. I'll bet that's a 30 volt Zener. I guarantee it is, because there's negative 30 volts here. Well, we're not going to get that negative 30 volts unless we get the negative 56 out of here. Well, is our 100 ohm resistor any good? Well, that's not even where we're measuring it. We're measuring it right off the end of the diode. So R70 is right here. 100. Whoops. Okay, here's R70. And we got 100.92 ohms. Okay. Well, let's see. So, what we got, this portion of this thing is half wave rectified. No, full wave rectified. For 56 volts. The minus 55 volts is half wave going into this cap here. And it's just dropping down. So either something is sucking it down, or, wait a minute, that's almost exactly 25 volts or so, is almost exactly half of what I should have. I wonder. Let me see. Yeah, I'll bet you. I think I know what's wrong with this. Hang on, I'll be right back. I gotta go get something. Okay, I'm back. I'll bet you. Here's a little trick for those of you that do any kind of repair on this older kind of stuff. That this could throw you for a loop if you're new to this. I want to show you. I'll bet you I know what this is. We have C22. Let's take a look at the schematic again. We've got C22, which is a 200 microfarad, 150 volts. They overdid it on the. That's good, 150 volts. But if this capacitor right here, if it's not working, if there's no capacitor at all here, as far as the thing is concerned, that's exactly what you're going to get. And we're going to find out, and I'm going to explain to you why in a minute. First of all, let's get the cap meter. Here's my little capacitor meter. Make sure, for sure, because you put a voltage into these guys, you'd throw it out the window. Make sure, for sure, this thing is shorted out. And it is. Alright. So, we'll put the plus on plus. And we'll put the negative on negative. It's a 200 microfarad capacitor, so... Zero. It's not even... It's a negative. It's not a capacitor at all. There's no capacitor there at all. That's what I thought. Okay. And that's a big old honker, too. Let's Well, since that's not there at all, we're just going to cheat. I got a couple of clip leads. We'll do this the old-fashioned way. Clip lead there. Clip lead there. Remember to go to the ones it needs to be to. This is 100 at 450 volts. 100 microfarads, 450 volts. There's only 56 volts here. Well, if it's 56 volts. So we're going to put that down right there. Get it away from my fingers. We're going to hook this back up here. I got a good feeling about this one. Because I've been doing this an awfully long time. Okay. So, we got to go to the non-cathode end of R16. Let's bring up the meter, or CR16, and we'll turn it on. Ready? Oh, take it off of ohms. It won't hurt the meter, but a lot of this stuff does not like shorting things to ground, which the ohm meter would do. So we're on voltage now, and we turn it on. Look at that. 55 volts. So we got exactly what we're supposed to have there. The other side, 55 volts. If we go and look at our Zener over here, which is CR20 at R79, CR20 at R79, we want the non-cathode end. It's right there. There's our 30 volts. Yay! We have a working machine. All because of that. All right. Let us just kind of think on this for a minute. Hold on, I'll be right back. Okay. I'm back, and I am going to use paint. Plain old paint. I'm no artist by any stretch of the imagination, so please forgive me. But I want to show you why this happens. Let's just draw in black, fine. This is a sine wave. It's kind of more of a triangle wave. But there you go. With zero crossing. Whoops. All right. Let's draw a line. Line. Zero crossing right there. All right? Well, what happens when you have when you're one half wave rectified is you are going to take a box. You are going to have this portion of the sine wave being rectified and quit that. And this portion down here gone. It's not there. And it'll repeat that all the way across for every cycle that you have. So you're going to end up with that bump, and that bump after the end of your diode down here. If you don't have a capacitor, that's exactly what you're going to see. Now, you put in a capacitor, and what happens is it gets up to the top, it charges the capacitor, and somewhere around here, the capacitor is charged and sort of slowly, it'll drop a little bit, but it'll keep it there along the top, and it'll charge. And I'm not that good with paint. Okay. And it'll do the same thing over here and keep it charged So what you end up with is your voltage is now going to be from, this section here, which is your whole voltage, instead of missing this bottom portion. So because of the capacitor charges up right here, and then it keeps that charge for a period of time until the next time it gets to charge up, and then it keeps that for a next time. So what you end up doing is you end up coming up with a lot more voltage than you do if you just have the lumps, just these lumps. Does that make sense to you? I hope so, because that's what happens if you don't have a capacitor in there. Now, we also could have seen this mess if we took a scope probe and take off my jumper here, take my scope probe, hook it up to ground, which is them little guys right there. All right, and I'm going to put this on AC coupled. Let's go to the scope. All right, and the scope I want on channel 2 because that's where I'm at. Turn off channel 1. All right, we can get rid of the TFT. Okay, and we'll turn this on. So now we've got our 22 volts sitting here. If I look at CR16, which was the end of the where we were looking, where we had our 22 volts. Look what you got. Slow this down. Slow it down, I said. There's what you got. You got hum. I'm on times 10, 60 hertz, times 10, 6.46, 60 volts peak to peak. Or close to times 10 anyway. That's what it looks like. Let's turn it off, put the jumpers back on. I like the way this thing bleeds away instantly. Putting the jumpers back on. And we'll take a look at what that looks like. Again, here's the same end, CR16. See that? See what it did? It I've got 200 millivolts per division. Now this is only a 100 microfarad cap, remember? So I got 600 millivolts, less than a volt of ripple on this thing. If I had the full 200 in there, it would be even less. So that's why, if your cap is bad or missing, or just, like this one is bad, it's that's what's going to happen to you. So let's take a look at it with, let's see what this thing says, because this is kind of my my go-to here anymore. I've learned to trust this. Just for fun and kicks, we'll look at this cap. And see what this guy says about it. Auto capacitor, go to plus, and go to minus. If I can get it on there. All right. All right. Get the scope out of the way. All right. So what we got here is 350 picofarads with a Yeah, it's not a capacitor. It's just nothing. Let's go on the one next to it just for fun. This guy is supposedly the same thing. We'll go here and here. Ugh. And see what it says. It says 201 microfarads. It's only 70 degrees. But then it's in circuit, so that you can't really trust that. But it is 201 with an ESR of about 285 milliohms, 0.285. So that's good. That's at 1 kilohertz. What's it going to say at 100 hertz? There we go. 226, 82 degrees phase change at 0.94 ohms. So that's a good cap. Let's check a couple of others. Let's see what we come up with. I don't know what this one is. $224.819. That one's good too. These are all singles in here. That's interesting. What's this guy? This thing ain't quick, but it's fairly accurate. This one's 500 microfarads, 86 degrees, negative 86, with 0.172. That one is good. We'll check this guy here, and it says what? I wish that thing would show up better. 500 microfarads, 0.150 and 87 degrees. Yeah, so it's one bad big filter cap. I wonder if these guys are any good. We'll check these little guys here. $111 microfarads, minus 82, 1 ohm, 1.8 ohms. And that's supposed to be what? 100. Okay. This one's at 50 at 50. We'll try him. Remember, this thing's, I believe, from the 70s, early 70s. What's he showing? In circuit like this, you're not going to show good readings. Yeah, that one's actually reading across the something. Anyhow, there you go. So we got to replace that cap. I wonder. I don't know if I've got anything 200. I didn't see anything right off the bat. Suppose I could put a couple of hundreds in there, 2 of them. But we got to fix that. Huh. Well, ooh, I don't like the looks of that thing. That's got goo all over it. I'm just going to check it real quick just to make sure. Yeah, you can see that. And 2.1 ohms. $20 microfarads. This one's made for checking things in circuit. Ah, that one's not good. That one there's not measuring anything. The one next to it's the same. We'll look at that. It's 2.6 ohms. These guys we measured over here, that's 0.6. Yeah, remember when we measured these guys too? 0.3, yeah. So this is agreeing with that. Alright, well, I got to find a capacitor to replace that with. I'll be back in a minute. Okay, the only thing I could find was this. I'm going to have to actually order something, I guess. we'll see what happens when I get this thing running. This is Nichicon. It's a 270 at 400 volts. So what we're going to do is we're just going to tack this thing in here for now so that we can actually test this thing. So let's try Mr. Carlson's way of doing this. We'll cut the end, cut the curl off the end of the post here where it's curled on. I can't do it there. Unfortunately, there's more than one thing here. There's one. Boy, they wanted to make sure they didn't fall out, that's for sure. Okay, these two here. They get twisted together. I mean, we're doing this for now. We're not doing this forever. Okay. And they get... This is just to see if this thing does work. So we'll put these. Everything is turned off. I'm disconnected from line completely. All right. Yeah, that thing will sit right there. Okay, I guess. Yeah, I'm going to have to get something that'll fit nicely there. I'll have to look into it. I don't know what exactly I'm going to get. Alright, now I got to get these guys off of the negative post. This is the one I was able to cut the nub off the end of it. There we go. Okay, they came loose pretty easy. Alright, there's one. There's another. Another. Mr. Carlson does this thing where he'll cut the where it comes around, the curls around the hole where they put it through. He'll just cut it off right at the edge where the curl is on the other side, and then when you heat it up, the whole thing just comes off real quick. It's really, really nice idea. Works great. How am I going to do this? Alright, I got a little extra here I can use with these guys. Boy, that is some really good wire. Well, it is Harris. I mean, this stuff was made to pretty much run forever. And it does. I wonder how long this thing was in service. like I said, don't be yelling at me for the janky way I'm doing this. I'm only doing this because I do not have one to fit here, and I want to see if this thing works. And I realize just how janky this is. Okay. Not hitting anybody. It's out of the way. Good. That's what I wanted to see. Okay, so let's turn on the power. Nothing went bang. Good. Ground, and we on voltage. Yep, we're on voltage. Bring up the meter. CR16. 55, negative 55 volts. CR17, positive 55 volts, just like it was made to do. All right. Perfect. So now, how do we hook this thing up? Well, I don't know. Like I said, I've not worked with this. Let's tell you what, let's bring up the meter, or the manual here. I can make this a little bigger so we can see this. Operation. Since the operation of the solid state limiter is automatic, it's necessary to make only initial calibration after selecting its mode of operation. Several of the controls are for factory calibrated use. Input level control is on the font. Recovery switch S1, position 2 is a normal operating position. Position 1 for faster. Okay, below normal, medium. Positive peaks selector switches should be set to symmetrical for FM and TV use, even though it says AM on the front here. FM and TV use. On AM stations where the transmitter has the power capability of handling higher positive peaks, true, they may be set to 110% on the center position. All right, so let us get a jumper thingy here. And let's do that. And plug it onto the back. So we're hooked up to the meter, and our input is over here. Input red and minus. I mean, we're probably going to have to change a couple of caps. Remember, this one showed bad over it. This one over here tested bad. It's hard, though. It's in circuit. I don't know. All right, and let's take another one of these little guys. These are handy, but for audio, you do get interaction between the wound up pieces of wire inside of there. So you can't really, you can't bet on it as far as being perfect. You gotta make up special ones for that. So let's do that. Let's put it into the scope here. I believe this thing has a relay, or maybe not. So I got, what, 2 volts going in. So let's get the function generator up here. And let's get the scope up here. if I can find it. We're doing way too many things at the same time. Where is it? Scope. There. All right, there's the scope. And we got, what are we on? We're on 5 volts, 200 millivolts. Oh, we got something there. Let's let us, let's do this at 400 hertz. If this thing will behave itself. I keep losing my connection to this, to my meter. It just stops for some stupid reason or other, and says that there's no port connected. All right, you're just going to have to believe me when I tell you what's going on, because I can't get this thing to work. Try it again. No port. Okay, well, we'll just have to we'll look at the scope then. All right, we got a little bit. I'll just tell you what I'm feeding it. Manually, there's 400 hertz. We'll take it down to 1 volt for right now. And turn it on. Yeehaw! I think it wants less than 1 volt. Let's, no volts. Yeah. Starts to flat top right around half a volt. Let's bring that up a little bit so we can see it and spread it out a little. Yeah. See that? Now, I don't know if that is accurate or not. Let's see. We want to channel 2. Thank you. All right. It looks pretty good for 400, but let's see what it does. 1400. That's good. 2400. 3400. I'm all the way up to 10K. There's 10.4. Wow, there's 23K. That starts to drop off about 32. All right, let's go back down to 400. All right, now we got to find out if it even works. So, the way you do that, that's why I want to get this stupid thing working. It says it's connected now. Let's see. See if it likes me. 400 hertz. 0.5 volts. Alright, and let's do a sweep and see if the thing is at least linear. Let's go from 30 hertz to 10K. That sounds good. And let's watch the scope. Well, that's pretty darn good. I mean, it's flat as a barn door. Let's take it up to 20K while this thing's still working. And we'll do that. Yeah. That's pretty good. That's pretty good. And we got some meter movement too. Disable the limiter. Alright, so let's stop that. Go back up to, yeah. go back to 400 hertz, and the limiter, let's try 0.8. It is not. No. Let's try 0.1. There's 1/10 of a volt. Let's adjust the input. I don't know how this thing works. Remember, I've never used this before ever in my life. Let's adjust the input. There's my input. Okay, it works. Attack is going to be how fast it attacks. We'll set that in the center. Output. Wow, that's ugly. We might have a problem there. Breaks into oscillation. Huh. Alright, so what is my output now? I'm on 2 volts peak to peak. So about 4. Yeah. Okay. So I want to take that thing down to where I'm at, which is, what, 0.1 volts? That's just picking up noise. But what I want to find out is, will it change? Will it do anything? No, it does not appear to be doing anything. Well, it is doing a little bit. If we bring this down so you can see it all. If I hit, here is with the limiter on. There's with the limiter disabled. There's with the phase disabled. Phase enabled. Okay. All right. So there's limiter on. There's limiter off. Watch it. Yep, it's dropping. Okay. I want to get this to where it's a little cleaner. We're gonna have to. We're gonna have to go through and change those caps, or I am. Right now, I just want to get this thing going. You've seen changing caps before. I mean, come on, folks. How many times do you have to see that? All right. Limiter off. Limiter off. Bad. Let's take this to 0.4. Drop it down so you can see it. It's okay. So 0.4 and it's flat topping. If I turn the limiter on, yes, it is trying very hard to do it. Turn the phase off. Yes. So limiter off, limiter on. Yep. So it does work. Anywho, so what do we got to do now? Well, I gotta find a capacitor for that and go through and test the rest of these capacitors out of circuit and make sure that that I replace them. And I'm just going to have to tack these on the top, because I'll tell you what, I'm not taking these boards out. No. No, I'm just not going to. So that's the way it's going to have to be. Sorry about that, folks. But anyhow, there you go. The meter's showing something anyway. Wonder if that changes if we... Where did it go? Whoops. let's see, if we take this to, let's see, 0.8. Yep, the meter is functioning and it's doing what it's supposed to do. It's going into compression. Take it back to point, slowly goes down. 0.4. Yep, it's maintaining close to the same amount and it is working. So there you go. Hey guys, thanks for stopping by. If I run into anything else on this that's goofy, or at least, you know, weird or interesting, I'll put it back in, or I'll make a video of it and show you that. But for now, it appears to be working. Got a couple of bad caps I need to place. I got to find one for that fits in there. The rest of these all tested good, but we're going to leave it on the bench for a while to make sure that it doesn't burn up. Anyhow, thanks for stopping by. Till next time.